And it's mainly just to go and why. So I'm Peter Goodwin. I after the pre-sales side of AAD and in my team, and we work closely with all the reps and with all you guys. And what we're going to talk about today, just a quick introduction to IP and looking at the position that our customers. And more importantly, with our customers today, seems to be the way of make it better together, because they're all breed solutions, whether it's a firewall, whether it's an IPS, but they're all siloed. If you can start making the whole ecosystem work better together, you get more benefit from what people have bought. And I'll wrap up with a little bit of competitive analysis of where we stand against most of our competitors. The following sessions around DNS security, I'm going to do a competitive bit on that. So this is purely just on the platform and the DDI aspects. So why do we do what we do? Right? Nick said it is old now. Why did they start it? The founders started this to make people's lives easier, right? Because manually managing Microsoft Excel spreadsheets, DNS and DHCP, it's a pain. And it takes a lot. So they started a whole product and company based around making customers' lives simpler and easier, right? That's what we do. We make it easier to control core network. And when we talk to customers, there's always three questions that both we need to answer from a customer, and also that customers want to look at back to us. And the first one is, why do they need a DDI solution, right? Second one is, why do they need to change now? And once they've decided they're going to change, why would they pick efficient IP? And there's the question, why does anyone need DNS, DHCP, and IPAM, DDI? And to be honest, they don't. When they first start, no one needs it. Everyone uses it. Each one of you at home does DDI. You have a DDI system in your house. I don't know your houses, and I haven't been spying, but I guarantee you have. You have a router that gives out IP addresses from of the IPs it's given out. That's IPAM. And the ISP, small companies start for more complex security. You hear me now? Get to a point where security is a focus point in the network, so they need to spend a little time. So if they're using a spreadsheet, it's free, right? And it works. But they can't automate anything from a spreadsheet. They can't validate that that spreadsheet is correct. Because they can't integrate something that does the discovery of the network with more than one sheet of an Excel, because there's probably a lot of people with different networks. So they'll start to get to the point where they then need to look at DDI. And it's important because you want a central repository of the networks, subnets, and IP addresses that customers use in their network. And those networks aren't just physical networks anymore. Cloud-based, whether that's public, customers need to understand what they've got running there. The physical network. They're probably some customers static. I need very many. Most rely on having DHCP for their clients. And everyone needs DNS to connect to services, to websites, to external partners. I don't think there's one person in here that would be able to tell me off the top of their head what the IP address of Google is. I wouldn't have a clue. That's why we use DNS. So what we do that then helps make their lives easier and less stressful. Well, we supply a range of appliances based around a hardened operating system that gives them security built in, gives them the ability to deploy high availability service or high availability for DHCP, for DNS, wherever they need at a size of performance that's applicable for the need. And then we also offer these integrations which allow people to be more agile, bring services to market quicker and deploy things quicker. So it's all about security, availability and agility. It's just trying to make people's lives easy. Okay. So, okay, that's why people might want to look at DDI. Why are companies looking now? As Nick pointed out, the market's been growing for a number of years, and I've been doing this 15 years, and more companies, you still find them that have got nothing and they want to change. You've got a lot of companies that are refreshing one system to replace it with another. But mostly there's a bunch of initiatives that customers are doing. And there is that term digital transformation, which annoys me to some extent because it's just a constant thing that's happening. You know, everyone talks about, oh yeah, we're doing a digital transformation project. You've been doing it since you put a network in. It's just the evolution of networking. But there are some trends within it. And different customers are on different paths within this. So cloud first is an initiative. A lot of customers are picking that up. Conversely, a lot of customers are moving away from cloud back to private data centers. They might still be putting virtual in place, not seeing the benefits of AWS and Azure they wanted, so they're moving back on premise. And the remote workforce, right? COVID was a pain, but what it did show companies is that they don't need people in the office 5 days a week, 8 hours a day. Mostly the workforce is partially in the office or working at home nowadays. But that brings its own challenges then. Because how do you secure what people are doing when they're not in? And we'll touch on that a little bit more later on. The Internet of Things, you know, how many people now see cameras everywhere you walk around the streets? I mean, if you go into the UAE, into Abu Dhabi, I think there's 80,000 cameras just in Abu Dhabi alone. Everyone's got heating and ventilation that's remotely controlled now. Everyone's got door entry systems. I mean, I've got a washing machine that sits in our utility room. The damn thing. My daughter can tell when her washing's done, even when she's wandered off to the shops to buy some ice cream. Doesn't tell me when mine's done, but she'll tell. Those devices are generally unmanaged, so it's difficult to see, it's difficult to know where they are, it's difficult to see what's on them because no one thinks about the management of it. Zero Trust I'll park for now in the next session. I'll bore you to death with trust for a little bit later. And then the SD-WAN infrastructure just means there's an awful lot of stuff out there that you just don't know because you can't see it. If you can't see it, you can't control it. You can't secure what you don't know. So most of the orders that we DDI you the or it's too late. We want to do DDI. These are the best looking people. There's got to be another reason. A lot of it comes down to the fact that it's a very flexible architecture. The fact that it's reliable, resilient, can be deployed where you need it on different platforms, whether that's cloud, private, public, or physical boxes, or even just buying a Dell server, installing and running it on that. Talk to the cloud stuff. We do network discovery to find out what's actually in the physical network and populate that into the GUI. People can see what you've got. Can't see. Manage natively both Microsoft and Linux-based DNS DHCP servers. Because some customers want to have some control over stuff they've already got before to a migration. We can do DNS security. Again, I'll park that for now and come on to it later. And we can also integrate with SaaS platforms to start leveraging a little bit more about those. The likes of ServiceNow. We can pass information to Umbrella. So if Cisco users have got Umbrella for protection, we can put on look at the information to identify end clients. I'll skip this because we're going to talk about it tomorrow. But all of this is delivered on a bunch of appliance platforms. The underlying software is the same. Right? So operating system on FreeBSD. And then the products come under the four pillars of DNS, DHCP, IPAM. DNS security kind of has its own because it's fairly important as a standalone product suite. And management is GSOE or global server load balancing done at the DNS. A10 and the rest, but a lot of the time you don't need functionality of A10. The rest you can do a lot of what they do, load balancing servers and resources. The appliance from very small ones way up to increase different platforms. So why are we different to our competitors? Well, we think we've got a simpler architecture that's easier, has everything in one box. We don't have a lot of other boxes to do recovery and whatever. We have some architectural change differences between us and our competitors that give us an edge for DHCP, where we're very high performant, and also for DNS, where we've got the fastest DNS server on the planet, 17 million queries per second or more. We've got some patents around DNS security and how we are generating our stuff, which with other things. And I've be because of the number of IP addresses, could be the number of services. It's just a quantitative requirement. As time goes on, that graph is just showing that you're going to end up doing more. But the resources don't increase commensurately with that. You know, customers aren't throwing people at the problem. So every customer is on the graph. Might be down there, you know, where they've got enough resources, the needs they've got today. But when they get up here, there's a gap. Yeah. You can have more resources. But I think we've already established that problems have enough to do. It can work harder. And on a show of hands, who wants to work harder than they're working today? Does. The other thing they can do is to automate a lot of the repetitive processes that they're doing today, get them automated, so that they can do the more important things and the automation stuff is taken care of. And the figures and numbers that get around, I don't know how long it takes for someone to register an IP. If they're doing it IP, someone's to record, someone's actually got to respond to it, find the next one, tell what the IP address is, got to go and request that a DNS name is made, probably a different team, for the IP address to the A record, and that's probably a couple of days at best. Now, I worked at Vodafone in the UK in the late 90s, and if you wanted to make a firewall rule change, it was a 3-week process just to get one rule put in a number of firewalls. So if you can automate stuff and you can start to drag that time down, one, you're freeing up engineers, two, you're making it a lot quicker to do things. That's got to be a benefit to the customer. That's why a lot of the time when we see RFPs coming from customers, it's about what automation integrations we can do. And a lot of the time, the customers are facing the same challenges across the board, whether it's an organizational thing where they just want to change how the actual business is running, and maybe they don't have the right skills in the right place to do the right things. It could be that they're implementing a solution that gives them technical challenges. There's an awful lot of different things that we can come across when we're talking to customers about how they're going on their automation journey. And most of the time when we look at what they're trying to do, DNS, DHCP or IPAM is kind of in the mix somewhere. Mostly we see in legacy systems where customers have integrated with APIs to use some of the older platforms that still exist, and they then need to change those. And a lot of customers don't have a single source where they can see everything they've got in both the cloud, the physical, and what they've got for a plan. So being able to put something in place that helps them get to that point means that they can actually accelerate their automation. So if you don't do an integration with DDI and you're trying to automate the network, it just doesn't make sense. You know, every device needs an IP to be on the network, whether that's from DHCP, whether it's statically assigned, you need an IP. If you've got the IP, you probably want the name to go with it so you can access it. So what do we do as far as integrations? And there's a number of them. First thing is we can integrate with the cloud operators. So Azure, with AWS, with Google, ESX, we can integrate with those to find out what's in them, what's running, who owns it, get some metadata, stick that into the system. You can see what you've actually got in the virtual environment. You do that with the physical as well. We can then integrate with orchestration platforms. So some of the bigger orchestrators, but also things like Terraform and Ansible, where people can have playbooks to drive what they want to see as infrastructure, both from a DNS DHCP perspective, but also for other systems. So if you want to spin up a new database server, you need an IP address, you need a name assigned for it. If that's automated as part of the orchestration platform, then everything becomes a lot quicker to run it up. We can also run our solution as containerized DNS DHCP if needed. So if you want to run small containers for DNS and DHCP in small remote locations, we can do that and still manage it centrally. And then if you look at how we integrate with other platforms, there's basically three options. I'll start on the right-hand side where it's a pro code thing. We've got PEB in the room that can explain what we can do from a PS perspective to do bespoke customizations if needed, or integrations that require a bit more coding. But typically, the first two are the way that you would do it. Either no code, where it's just a webhook that you integrate, sending information or pulling information out of the solid server from a remote system, or it's a low code where it's customization with some bits to tie it together. Mostly, if you've got requirements for integration, it's probably worth running it by the customer solution architects, so Chirag, Rasha, and the team, just to understand what we can do easily within the product if you don't know. And if we don't know, we then go to PEB and his team and we find out whether or not something is possible. Mostly, it's normally possible. There's always going to be the odd exception where there's something we can't do. It might be because it's a stupid idea that the customer has. But generally, we would look to see how we could do that. There may be one or two ways of doing it. And if we look at the top 10 integrations we've got, so ServiceNow, we've got two. We've got the old way plus the new flow-based integrations. So if someone's using ServiceNow as a trouble ticketing system, we can integrate with that. They can pull IP addressing out, find what the next one is. They can put stuff into the system if they need it. A number of cloud plugins. Azure's there, AWS. With the latest version 8.4, we brought the Meraki integration in, so we can start to see what's going on with Cisco Meraki from a IP and DHCP perspective. ACI. If there's any universities that are using ClearPass to clear their students for access, we can integrate with that from solid. We've got resellers in other regions that sell a lot of extreme firewalls. And we've got one reseller in Germany that every time he sells to a new customer extreme firewall, he bundles a small IPAM that just integrates with the firewalls he's pushing out. So they get the information from all the extreme firewalls into IP address management. We don't get involved typically in what they do. We just get a PO for a small IPAM system. They know how to integrate it with Extreme, and off it runs. I mentioned Terraform and Ansible before, just to be able to do infrastructure as code. I don't know anything really about data. What I have got is a deck, and I presume we're going to share the decks with you. I've included all, or a set of slides on all the integration points we do at the end of the deck. I'm not going to go through them today because that would be really dull, but they're there if you need them in the deck. 2FIN as a firewall policy manager, integrate with that. There's a couple of videos on YouTube if you want to see it in action. And then we can manage natively Amazon and AWS DNS plus Azure DNS. So from a competitive perspective, these are the ones we come across, or Infoblox everyone knows about. Blue Cat, we don't see a lot in this region, but they do operate. QIP is now owned by Signal Labs. It used to be Nokia, and before that, Alcatel-Lucent. They still sell it. They still make it. They don't do much with it. BT Diamond IP, you still come across it occasionally. And then if they actually did do a Magic Quadrant and Gartner included the normal kind of free stuff, Microsoft would be by far most installed better than any of DDI vendor because it's just ubiquitous in Microsoft Active. But against, I mean, the blocks, they are expensive and continuing to increase their pricing. And there is a philosophical difference between the way Infoblox bring their platform and the way we do. Infoblox lock it down completely. You could change to that platform. We take a more practical view and allow certain changes. Neither approach is right, neither approach is wrong. It's just two different approaches. Sometimes difference to the camera if you could change. And they do have to introduce this universal DDI initiative, which you've probably seen over the last couple of months, which to me is basically they're saying that the strategy we've had for the last 6 years was failed because they cannot continue with two different platforms that don't talk to each other. Now, currently, they don't talk very well. That might change in a few years. It will take them a long time to change it. But they've just come up and said having separate cloud and on-premise managed separately doesn't work. Blue Cat do tend to be more focused on North America. They are opportunistic in that they will target certain opportunities within customers when they know about it. They don't really have a fully featured DNS security offering. But from a DNS, DHCP, IPAM perspective, yeah, they do that. QIP hasn't really had any investment in a number of years. It is cumbersome, but most companies that have QIP have customized it a lot. And that tends to be, if you're replacing QIP, then you need to consider which integrations customers with it, because some of them can be quite complex. I don't see BT Diamond hardly ever. Come across it, I think, in the last 3 years, twice in RFPs. But generally, never got to a point where it's been a bake-off between BT and anyone else. But Microsoft, it's free. You know, everyone uses it. If they've got Active Directory, they're running DNS and DHCP. There are some reports that are around that are independent reports that recommend customers move away from running DNS and DHCP on a Microsoft platform. The challenge is persuading the Microsoft teams within customers, and it gets political. There are some other things, right? Some customers will turn around and say, well, we've got a web proxy. We don't need DNS security. We just use that. Normally, a bit of a misconception because the web proxy still needs a DNS server to resolve the names. And typically all it does is it hides the user from the DNS server. So you don't know if someone's making a malicious query or not. So there is an argument that you shouldn't use a proxy for DNS. You should use it for what it's designed for, which is proxy in the web access. And then you'll also come across next-gen firewalls that say, oh yeah, we can do DNS protection. And I'm not going to say they're lying, because they're not. They do DNS protection. They just don't do all of it. And one of the challenges that next-gen firewalls have is they're typically put at the perimeter of a network. So they don't see anything that's going internally. And a lot of the time they lose the IP address of who the client is, so they can't tell you who's creating any issues. They can just stop some of the issues. And they can't run that many indicators of compromise. So if you look at threat data, they really can only get to about 350K worth of indicators. You know, on a good DNS server, you've got multiple million entries in the feeds that come through. If you're running our Guardian feed, I think it's around 8 million or so now, there's a tremendous amount of threat data in there. On a next-gen firewall, you can only run a very small amount. Still need them, not going to replace them, but you just need to be aware of what you can look at and where you can look at it. We tend to come up against the likes of Palo Alto and their DNS firewall thing, or whatever it is they call it, quite a lot. And some of the challenges are they can't keep state of each individual user because they're seeing a stream come from a DNS server. They don't have full coverage of the entire threat landscape. To be fair, no one does. But theirs is a smaller view of it than anyone else. And if they're getting hit with volumetrics, it's very difficult for a firewall to do it, which is why the likes of Arbor and the rest get put in to do the volumetric. I would contend that seeing a customer that's bought Arbor as a product is a good sign that they're treating denial of service attacks properly. But doing it at the DNS level isn't the way to go using Arbor. For floods and traffic level kind of attacks, yes. But for DNS, you're better off putting a server in place that can handle all the traffic and then attacks. So why should we think efficient IP to answer that third question? We have a simple, a solid system to a network, and then to hook multiple systems up to central management and just control everything from one place. Even if that's using an API from a different system, it's still one place for the external systems to go to control the DDI solution. We're more flexible. We can customize it. We can put security policies where customers need them at the edge, and we can do it down to individual user level if needed. Normally it's a group of users, but you could do it to an individual user if you need it. And because we're doing it at the DNS level, it's the first thing that any transaction starts with. So why not use that as the control point and then stop any of the further traffic from hitting the network? And generally, we offer a lower total cost of ownership than most of our competitors. That's pretty much everything I was going to talk about in the first session. Is there any questions? And the other thing, I was talking to a couple of guys last night. You can call bullshit on this, right? If you want, you can just put your hand up and say, well, so what? You do DNS security. So what? What do I care about that? You know, you DNS, DHCP, IPAM. So what? If we can't answer the question, so what? The challenge. Questions, you don't have to put your hand up now, but come and see me, see the solution architects. This shouldn't be difficult stuff to actually position to customers. It's bloody difficult to get them to buy it, but for them to understand shouldn't be that difficult. It's just whether or not they want to pay the money for it. So, saying that, any questions? No?
Obviously, so you guys, maybe most possibility that this is the what this so the standards maybe part of the bit.
Okay.
So the thing.
I'll talk about it more in the next session, but simply, DNS firewall does the reputational. So you get a set of threat data in RPZ format. You check every query against that set of data. Right, we do that. Infoblox does that. Blue Cat does that. Microsoft do that. I don't know if Blue Cat sell their own set of feeds, and we certainly do, and some other vendors do. Between most commercial feeds, if you have a Venn diagram, and I think I've got it in the next deck later, if you did a Venn diagram of the entire threat landscape, you'd have circles of where people like CrowdStrike and Farsight and Efficient IP or whatever, where our threat data covers. Very little overlap between them because we all get the data from various places. That's just on the reputational side. Then you can start looking at signature-based protection where you can identify if someone's using an older version of iodine to do DNS tunneling because the packets come in, there's certain things in the packet. That's a fairly simple thing to check for. Where it gets more complicated is where you want to start looking at what individual clients are doing. So keeping state of what your machine is doing from a DNS query perspective. Now DNS, it's UDP, it's fire and forget, no one cares. If you want to understand if someone's trying to do any kind of data exfiltration, infiltration, or DNS tunneling, you have to look at what that client is doing. There's only two vendors that do that, and that's us and Infoblox. Right? Blue Cat don't do that bit. Now, they probably will at some point, but they don't today. That is probably the biggest differentiator between Blue Cat and us, is that they don't do that behavioral aspect. They're not looking at keeping state and trying to understand what your machine is doing from a DNS perspective. They can check each query against a bunch of data. Great. You need it, but it's not rocket science. To do the behavioral stuff, you've got to start to keep state on essentially a stateless protocol. And we do that with DNS Guardian. Is that okay? I think I've got some more stuff on that in the next slide deck, but I'm not sure. Any other questions?
Deploy the solution to the multiple from the center location or CP solution to the multi branch from the centralized location or over the SD-WAN or MPLS cloud.
So we can deploy the DNS security wherever you need it. Typically, if you're looking at consuming the threat data, you can either pick that up from individual servers going out to the internet, or you can pick it up from one and then push it around with it. But if you're looking at doing the behavioral side of things, it's based on DNS Guardian, which we can run on multiple systems wherever you want, but it's all controlled from one place. So you put the management where you need. That can be cloud-based. It could be on a Dell server running in one center. You can run it if you wanted to. You put the management where you need to have as a DR solution somewhere. You deploy servers or the service delivery aspect of a solution, appliances where you need them. Based, if you've got a campus and you've got a massive building with one data center in it, that might be a slightly bigger box than it would be if it was a small office with 60, 70 employees, but you wanted local service there. And when it comes down to doing the design and the architecture, so We do have those that can do that on their own, and they'll just to make sure that what they're using. We do have partners that ask us to get involved and work with the customer to do the design and architecture based on their needs. It normally starts with a qualification document, which I'm sure we've probably shared with your technical team, that is asking things about how many servers have you got, what roles do they do, zone, that kind of information that we then work out sizing for. But the best thing is to stand in front of a whiteboard with a pen, just draw it out. Because you get more information from the customers when you're actually going through and architecting it. But if I think I'm answering the question correctly, we can deploy places, we can DNS this to the user. But architecture varies from customer to customer. Some go fully distributed, some go centralized. It's choices, really. Does that answer the question? Cool. Any others?
Hello, Peter. We heard last year about integration with a lot of ecosystems, and thank you for this. Actually, we saw also that you integrate with Cisco Umbrella, and considered as one of the competitor in this field. I need some highlights about this integration and the vision of integration with Umbrella and other working in the same field.
Okay. So with Cisco Umbrella, typically they have an on-premise module that you can run for DNS that supplies Cisco Umbrella with the kind of the user information. Because once it gets to the cloud, you've lost who the user is. You know, it's the packet comes from the public IP address that you're using. You can't see the guy who's on a private network in building A down the road, right? So they put something on premise that will pass, acts as kind of like a DNS server or proxy that passes to Cisco Umbrella the client information, what the source IP address is or whatever. We do that from our recursive DNS server. If you want to look at, we've got documents that describe how to configure a solid server to pass the stuff to Cisco Umbrella. Because there's certain fields that you just put into the DNS packets that are leaving the network that then identify the end user and give Cisco Umbrella the information it needs so that you can see the visibility in the Cisco Umbrella GUI when you're looking at what clients are doing. Now that's a document that if you see one of the CSAs, we can send you that document and it goes through the steps you need to configure a solid server. It's not rocket science, it's pretty easy. Is that okay? Any other questions? I mean, we're actually pretty okay on time for this one, so yeah.
Also use cases with
ClearPass?
Yeah.
So the question was, what's the use case for integration with ClearPass? So typically, I've seen that more within academia, so universities primarily, where they've got, I don't know how many students a uni has. The one that's just down the road from where I live's got about 20,000 students. And students are an interesting breed because they don't act responsibly when they're acting network. They're always trying to hack networks. So what universities generally want to do is for a student to register somewhere the MAC address of the devices that are going to be used on the network so that they know it's a legitimate student device. Whether it's a phone, an iPad, a laptop, or whatever. They want the MAC address to allow them access. And they want to know when they come on the network that it's who they are. So they use ClearPass for that. So integrating that information with IPAM, you know, if you've got a lease in IPAM that you're giving out, it would be nice to know that this IP address matches this authenticated user in ClearPass. So it tends to be, you could probably see it in some enterprise, corporate customers. More than anything else, I've seen it inside academic customers. But PEB would know a bit more about corporate users of it as well. But generally, it's unis that use it more than anything else. I mean, if you look at a university, it's like being a service provider for a bunch of 18 to 23-year-old professional people. They're the ones where ClearPath gets used more than anything else.
Thank you.
Any other questions? So I think you're all catching on. It's a break now. So, Emily, how long have we got for a break? 15 minutes. So is coffee and tea outside? So I believe coffee and tea is outside. If it isn't, Emily's the girl at the back and you can give her a bit of abuse. And then in 15 minutes, if we're back in 15 minutes, I'll start on the next slide deck then. Thank you. Okay, is everyone coffeeed up and are we all ready?
That's just a while. So,
You'll see a common thread within this, which is meerkats, because I kind of like meerkats. They're cute, the little cuddly things, but there is a point to it. Okay, so I haven't changed my role in the last 45 minutes, so I'm going to put that down as a successful last session. We'll look at the context of DNS security in today's market. I'm going to look a little bit about the kind of things we look for in customers when we're positioning DNS security. And then I will wrap up with a little bit on competitor analysis at the end of it. So if we look around industry as a whole in all different verticals, DNS is now one of, or if not the top vector for attack. And there's a lot of reasons for that, which we'll come on to in a minute. Most used DNS at some point in its life cycle. And if you ever look at what the kill chain for malware in a network, it might use it when it's doing its initial reconnaissance. It might do it when it's trying to do its lateral movement. It will probably use DNS at some point to try and exfiltrate data. But then there's also the aspect of people trying to compromise DNS, so taking DNS servers down. Because if you take DNS down, you take a network down. And a lot of companies have seen DNS be attacked. A lot of companies don't know they're being attacked, but they just think their DNS server is being compromised somewhere because the performance is dire. So there's three main reasons why DNS is at the top of the list for attackers. The first one is it is mission critical. No DNS, no network. There isn't a network that I've been to see in a customer that doesn't rely on DNS at some point. It's like going back to what we talked about before. No one has a feed network. DNS used it's also really easy to exploit. Everyone knows it. It's been around for over 30 years now. It's an open. It uses UDP, and you put the IP address of the source in the packet that you send so people can spoof IPs and send the responses anywhere. It's really simple to do a DNS amplification reflection attack. And it's relatively true that most people don't even consider DNS when they look at security to start with. More and more customers are considering it, but it just works, right? It's in the network. Don't need to think about it because I make a query, I get an answer. What else do I need to do? And when you look at the different types of attack, can you read? Yeah, it's very difficult to read this one, but from looking at the different types of exploit, looking at how people use phishing as a kind of a way of getting information and getting people to click on things, that uses DNS in a way it's not really supposed to be used, to send people to the wrong place. DNS gets used in all of those. The amplification reflection, the fact that you can put the source IP address as someone else means I can send a DNS query to a server and that response is sent to somewhere else. And on the internet, there's around 1 million or more open resolving DNS servers. It's not just the 8.8.8 for Google or the rest of them. There's a hell of a lot of open servers that if you send a request to, it'll respond. Doesn't matter where you are. So if you've got 1 million servers and you have a 1 gig line coming into your house, you can craft a set of requests that are around 53 bytes in size each, which means you can send them to 1 million servers fairly quickly. And if you craft the DNS query correctly and you put the IP address of where you want to send it in the same one, but you send it to 1 million different servers, they're going to respond to that each query by sending the response, which is where the amplification comes in, to somewhere else that's the target. And a 53 byte query can result in around 4K or more as data being replied to as a response to the supposedly source IP address. So you have the reflection being, I'm going to send you a request, send it to the target. The amplification is, I'm going to send you this much data, but you're going to send this much to the target. On a 1 gig line, you can generate around 300 gig of traffic really easily. And that is how you do a denial of service attack on someone else. Uses DNS in a way that it's designed for, that it works, and is legal. Well, legal is probably a touchy thing, but you can do that reasonably easily. That's what a lot of the distributed denial of service attacks use. And each of these attacks costs money. And it's going up. So from 2022, when it was around 940K per attack on an enterprise customer, the average is now about 1.1 or more. And it's not, the cost is always a bit of a difficult one because it comes into a lot of factors of how long the network's down for, what that network is actually supporting. I mean, if you go to a food manufacturer and you cause a production outage, it's not just the amount of time that the network's down, it's the amount of time it takes to replace all the stuff that's gone off while the network's down. In pharmaceutical companies, where they do a run of drugs, if that production run doesn't happen when it's targeted at, all the source stuff that's going to be converted or processed and put into a medicine has a time life that may go. That's an awful lot of money being wasted. I mean, I can remember years ago I went to see Heinz and we were talking about production of ketchup. And they looked at the fact that if they had a 1 hour outage on their production line, they lost the ability to produce 50,000 bottles of ketchup. Now, I would argue that's an awful lot less sugar going into the kids around the world, so it's probably a good thing, right? But from a Heinz perspective, they're losing 50,000 bottles of ketchup that they can't sell. And each one of those bottles is maybe $1 or $2 a bottle. So the money just adds up. And if people don't think about DNS security in real terms of how much is it going to cost to put this system in, maybe they should think about, well, how much would I have got if I'd have had 50,000 bottles of ketchup to sell? And we do get questions from customers on this that, well, we're supposed to be the experts on it. So what can we do about it? And that's why Rasha, Iyad, Tushar, Shirag, myself, that's what we're there for, is to be able to articulate to customers what they should be looking at doing. So if we look at a bit more detail about what we do as a company. So you'll see this slide in a lot of the presentations that we do, and it's around 360-degree DNS security. It starts with the platform itself. So it's a hardened operating system, doesn't have services running on it that aren't needed, and we can deploy it where you want it and manage it centrally. We can do the next bit, the actual looking at cyber threats that have been known and identified that exist within threat data that you can run on the DNS server, and again you can check every query against that set of threat data. And if it triggers, you can do a number of things. You can block it. You know, if it's malware, you probably just want to not respond to it. If it's someone trying to go to a URL, but the domain is flagged as having known malware associated with it, you don't particularly want to block that, because the user is just going to get a failed connection on their browser. They're probably going to phone the help desk and say, oh, the internet's not working, I can't get to this website. In that case, you probably want to rewrite the response and send them to a walled garden that controls the user browsing experience so that they see why they can't get to the site they're trying to get to, but they get closure on the fact that you're protecting them from going to a site known to be associated with malware. But that's just looking at that one-by-one query against the threat data. We have a unique thing where if someone triggers something like that, or any of the security events that come up, we can put them in what we call a quarantine mode. And I'll try and get a bit technical on this without going too deep into it, but what that means is once they've been identified as being quarantined, they cannot get an answer to a query that results in a recursive query leaving the internal network. But if they make a query that someone else has already asked for, that the DNS server has cached and has it in its memory, then we know that one's a good query, so we'll respond to the client. Now, mostly, we all do the same stuff. And I don't really care if you're in Saudi or India, Sri Lanka, the UK, we all do the same things. Social media, we all probably use the same platforms. If we were all in the same enterprise, we probably use the same internal systems, the same internal names. So the chances are, you make a query, the guy sitting next to you has already made that query. It's going to be in memory. But leaking data out, going to somewhere that's known to have malware, you won't get to be able to do it. You could probably do your day job, but you won't be able to do any data exfiltration or recursive queries. And we'll tell the security team that it's going on so they can do something about it. At the bottom line, at the bottom, where we're doing the identification of threats, we've got a team in Paris that just exist to look at DNS data that they're receiving from other customers and other sources and identifying threats that are active in other customers that we then share with the people that are actually taking our DNS feed. But also then we've got a lot of processing we apply to it so that you can see what's going on in the cloud-based reporting about what's going on from a DNS security perspective on-premise in the customer. And all that is based around DNS Guardian, which is our own DNS caching engine targeting very low latency responses but high volume of queries. So that's the thing that will do up to 17 million queries per second in a single instance. And if it's a virtual instance, we'll do up to 4 million queries per second. But we can also run it on the smaller appliances that only do like 10,000, 20,000 queries per second that you can put into small offices. This is the thing that's looking at the behavioral analysis of what the users are doing as well. So it's a purely caching engine. It does the low latency, high volume, but then it also puts the security at the user level. So we can start to track individual users, which we spoke about earlier. So if someone is maybe not knowing that they're compromised, or even if it's an IoT device like a heating and ventilation system thermostat, which we've seen hacked around the world, if that starts making queries it shouldn't, you want to be able to see that. Guardian has that built in. And then just the fact that we can do the high volume means we can absorb a lot of denial of service attacks that are targeting DNS by just answering the queries. What this gives us is a system that as a whole we can protect all the users where you need to protect them at multiple different levels. So it's a hardened appliance. It's pretty simple to do upgrades and deployments within the solution, so you should never see a service outage while you're going through this. And the fact that we have, it's a concept called smart architectures. I'm not going to go into that so much now. It's part of the training. If you're selling what we do, you've already come across it. But it just gives you the ability to push the policies where you need them easily and treat servers as groups so that you just push the same thing to multiple places. And we support DNSSEC if you need to do that, and it's to sign a zone is a fairly simple thing of pressing a button, that zone is signed. On the authoritative servers for that, people can ensure they're talking to the right DNS server. So Guardian is generally the thing that we recommend for any recursive or caching DNS within a customer. It has a place on authoritative servers as well, but it's primarily a caching engine. Because it's doing the behavioral stuff, it needs to see who the customer or the client is. Once it's done that, it can identify and track those individual clients within a network. And then at the back end, in Paris, we're doing the analysis on millions of DNS queries per day that come from a variety of customers around the world to identify known threats that we see in customers' networks. So that for the customers that you sell it to, they're getting the protection that's generated from a lot of bespoke kind of processes that I don't have a clue what they do when they're doing it. We've got a number of patents that are assigned for this. But the team produce a set of feeds that include things like newly observed domains, which are important to stop because no one launches a service on the internet, but they only registered the domain yesterday. Most legitimate uses for DNS, if someone wants to put a new service on, if Amazon decide they're going to put a Facebook lookalike.amazon.com, that subdomain would get created weeks or months before that service goes live. So if a domain is seen within 7 days of it being registered, typically there's a good chance it's got criminal activity behind it. Not guaranteed, but probably. And the fact that we're getting all this data from multiple service providers and customers around the world means we've got global visibility of it. And the one thing I would say is that the feeds we generate are not completely US-centric, which some of the vendors' feeds that you can buy in the marketplace, they're built in the US for US needs. Doesn't necessarily work when you're in the Middle East or the Far East, or even in Eastern Europe. A lot of the time then, they're going to block domains that you may not want blocked. So we produce a bunch of feeds. You can then consume them running in the DNS firewall. You can consume them on other vendors' DNS firewalls if you want to, but it's a standard way of transporting threat data into a DNS service via response policy zones. We also, with Guardian, can take it in a different format where we get much more data being able to be transferred and used. From a DNS firewall perspective, we can probably give you a feed that's got about 500, 600,000 entries in it. The Guardian CQF feed has about 8 million or more in it. It's a much more efficient way of transferring the data. So again, Guardian does the deep packet inspection on the transactions. So we're not just looking at what the query name is. We're not just looking at what the source IP is. We're also looking at other aspects of what's in that packet and then triggering based on it. The adaptive countermeasures I've started to talk about, where we can rewrite it, we can block it, we can quarantine people. We also have a rescue mode where, it's been a while since I think this happened, but probably about 5 years ago, the dying DNS service in the Northeast America was attacked with a denial of service attack. How that affected users was they couldn't resolve Facebook, Snapchat, Pinterest, various other social media domains that were hosted by the dying service. And dying have a global DNS presence. So mostly every zone is in lots of places. But the ISPs that you use tend to peer into one or two places to send their DNS traffic. And with this attack, they basically took down the dying servers in London and Northeast America. And I was in Saudi at the time it was going on. And out of the telcos in Saudi, one telco was still able to resolve Facebook, Pinterest, because their second peering went to Singapore. One other of the SPs went to America and Europe, and they couldn't resolve it. All they saw was the fact that they couldn't get to Facebook, Pinterest, and everything else, and that they couldn't resolve it on the DNS, so it must be the DNS servers that are at fault, right? No, it's the authoritative servers that they just couldn't get to the right ones. What we've got within our solution is a rescue mode, whereas if we've given a good answer before, so if 10 minutes ago someone went to try and get to Facebook, they get the IP address and they've gone browsing, we've cached that value in our caching DNS. And the TTL, or time to live value that comes with it, tells the DNS server how long that's valid for. And at the end of that period, it's going to re-query to get any particular changes that have gone on, but it will try a recursive query. If that fails as a serve failure, you can't get the server, we can give the old answer, which is probably the thing to do, because it's not the fact that the record doesn't exist anymore. It's the fact that we can't actually get to that DNS server. So we'll give the old answer for a period of time, which means that people that want to access Facebook, they've got the old IP address, it probably hasn't changed, so they can still maintain service. You don't want to do it forever, because it could be that the domain has actually gone. But for a period of time, we'll return the old information. It's just a way of maintaining service when it's not your DNS that's down, it's someone else's that's got an issue. And I think I've already mentioned this. We have two formats of how we can share data. The RPZ, Response Policy Zone format, any DNS server typically can pick that up. The CQF is the way that Guardian will pick it up, and you get a lot more data that way. And then we have the online cloud-based solution that if you're using Guardian, we can push the information in, where you can start to see more data on what's going on in DNS in normal operation. When it's actually working properly, you can start to see trends that mean it might have an issue that you don't know about. There are some attacks you'll never know it's a DNS attack. You'll just see DNS servers slow down. And it's the worst thing for a customer where they think the DNS server is just not performing. It's actually working. It's just the DNS queries are taking too long to resolve. We can start to see that kind of information in this. You might see a trend on meerkats on this, and there's a reason for that, which we'll go into in a minute. But if we want to look at what we do as far as giving people visibility within what's happening in DNS, what do we do about it? Well, the first thing is we can integrate with any SIM. We can send the events as a syslog entry to a SIM or a source so that you can see what's going on. If someone's making queries or triggering some of the security events, blocking it, rewriting it, that's great. But the security guys need to know about it. How do they get that? That's where we push the events into the SIM. The security guys can do something about it. They can't do anything if they don't know about it. So that integration is fairly easy to do. There's minimal impact on the DNS server, but you get the value of information in the SIM. We talked about the umbrella integration earlier, and it's about looking at both the inbound and outbound traffic, which Umbrella will see, the north-south, but then having Guardian on-premise protects the east-west traffic, and I'm going to go on about that a little bit more in a minute. So our recommendation for the way that we see Umbrella integration with efficient IP is that we do the on-premise side, and Umbrella does the cloud-based security side. Now, going back to what I talked about with the threat landscape, Umbrella has different threat data to we do. There is no overlap or minimal overlap between what we see and what Umbrella sees. So it's just an extra layer to put on top. The two-fin integration I talked about earlier, if you're using something like two-fin to push policy rules to multiple firewall vendors, it's nice to integrate that with DNS, DHCP, and IPAM so that you've got the information from the two-fin and the platforms you're pushing firewall rules tied in with IPAM. And essentially, it's about, DNS is that the first thing any transaction starts with. So having the visibility of what's going on at the DNS level gives you an indication of what issues you're going to have in the network after it. If you think about the entire threat landscape, you cannot ever get 100% coverage of the entire threat landscape because that includes zero-day threats that no one's seen before. So every vendor sells their threat feed. There is no one set of feeds that covers everything. And customers need to be aware of this because sometimes they'll get sold a particular feed and they think they're covered because they've got a feed from one vendor. It cannot ever cover all the needs. The customers need to be educated on picking the feeds that they need for the business they're in and the location they're in, because a lot of them are geocentric. There are a bunch of vendors that sell this. These are just some of the threat feed vendors that you can purchase commercial feeds from and from some of the free ones. The IOC to RPZ is a bunch of free ones that you can just download free of charge, use on any DNS server you want. And then if we go back to what customers are doing and the strategic initiatives that they're doing, there are a couple that really DNS security pertains to. And the main one that I would touch on, and I talk to customers a lot about this, is zero trust. And I always like these. These are the little guys, the meerkats, that live in communes of quite a few of them. And they're all in burrows in the desert. And what they typify is perimeter security. Because wherever there's a burrow of meerkats, there's going to be a dozen of these guys all looking out away from the burrow to identify threats coming. And they all stand up on their hind legs and they all look at the horizon to see where the hyenas and the lions and the rest of it are coming. And it's like perimeter security in the old days. You know, we all had data centers where we put a ton of products in to protect that network from IPSs, IDSs, web proxies, next-gen firewalls, and it was all about stopping the ingress and the egress of threats and stuff coming in and out of the network. But if you were in the network, you were trusted. And then Zero Trust came along. And there's no Zero Trust product. It's just a change in mindset. You know, and it's going from, if I'm in a network, I'm trusted, to, okay, I'm in a network, but should I have access to this particular resource or that particular resource? And one of the questions that I ask every customer I go to is, if I'm in a customer network and I'm sitting next to a customer and he lets me use his laptop, and I make a DNS query for any valid name in their internal zones, will I get an answer that's correct? And I know the answer is going to be yes, because that's what DNS does. You make a good request, you get a good answer. And the question I just ask every customer is, well, should I? Should I get an answer to every request I make? You know, I'm part of the sales organization in Efficient IP. If I go into the corporate office, should I be able to access the finance system that the accountants run?
Thank you.
I don't think our CFO would like that. But I could probably make a DNS request for finance.efficientip and get the answer back. And now I know two things I didn't know before I issued that query. I know it's a valid name. And I know the IP address. In a zero trust world, where you're trying to restrict people's access to the stuff they need to do their jobs, but nothing else, why should I get that information? And it's probably not me that would be looking for it, but it might be the malware that would be on the client machine that's trying to do lateral movement and trying to do reconnaissance. It's not just going to do DNS, it will do a number of other things, but DNS is one of the things it will probably try. Wouldn't it be good if you could see that before it actually started doing lateral movement, to identify the fact there's a client machine making queries that it shouldn't be able to see? And I think this really isn't rocket science, guys. For me, you've got two choices. You either allow unrestricted name resolution within a network, or if you're doing zero trust, you should not do unrestricted. You should start to look at what names people or groups of people should be able to access. And it's a choice customers have. And I've been to a lot of shows and trade shows where when you ask a customer that, it's kind of, there's almost an epiphany. It's like, well, why should you be able to access stuff that you're not able to access the systems for? I just think it's a no-brainer. It's not rocket science. And if you look at the four basic tenets of what zero trust means, you know, you shouldn't trust people. You always verify that they're allowed to do what they want. DNS is a really good point. First thing in a transaction, if they shouldn't be able to access the system, don't give them access to the name. And default to the lowest possible access, and then just tailor it so that people access the stuff they should, while giving that full visibility, while giving that control, and being able to manage all the policies that you push to where you need them and protect the users across the entire network. And there are a couple of use cases for this. Essentially, we implement allow lists that say people can access certain names, or deny lists that say people can't. And you can do combinations, which opens quite a few possibilities up. one of the main ones for me is IoT devices. Like, no one controls them. They're just dumb little things, thousands of them in networks. They should only make 1 or 2 queries. Now, heating and ventilation system, well, you need to be able to control the temperature, so it's going to talk to either the AC or the boiler to raise or lower the temperature. It might have a management platform that it also wants to do updates. Certainly shouldn't be doing anything else. So if you restrict it to just 2 queries, and if it makes any other queries because it's been compromised and it's starting lateral movement, which we've seen in thermostats, wouldn't it be good if the security guys were aware of it? Or you might have a set of guys that are accessing cloud services, and you only want them to access those cloud services. So again, you can do allow lists or deny lists to stop that. It is based on our DNS Guardian, and we have a module within that client query filtering. And I'll skip through to the end of this one. Let's go back one. So if everything is working correctly and the IoT devices have been identified, they've been added into the list, the lists say what queries those IoT devices can query. Right? Every other user is down at the bottom. They can do what they want. There's no access control for those. But for the IoT devices, we're putting in a list of who they are and what domains they can access. So if they make a query that's actually valid and allowed, then they get the response. If they make one that isn't, well, then they can't get an answer for that. And the security guys are now aware of it because we issue an event. And if I saw a thermostat make a request for something external that it shouldn't, I think I'd want to know about that. And if you just allow unrestricted access, you're never going to see it. So, looking at it from a DNS perspective as the first point of contact in any transaction has to be a good control point. You can put an awful lot of protection mechanisms in place using DNS. We've talked about a few already. And you could integrate that within the wider security ecosystem to give the visibility to the people that need to see what's going on. Because the sad truth is, in normal use of DNS, if it's working, everyone leaves it alone. You know, it sits in a corner, answers queries, life's good. And the customers really need to understand what the risks are. And we can help with that. You know, they need to be thinking about, okay, for cyber squatting or for people that hijack DNS names or zones by hacking into the registrar and changing who's responsible so that they can go in and make changes to the DNS without the customer knowing, that's something they should look at. They should look at what they're doing for DDoS protection at the DNS level, how they block malware and command and control, how they stop data exfiltration, because malware will use DNS because they know port 53 is going to be open. And the conversation changes depending on who you're speaking to. I mean, if I'm speaking to a network engineer, they really only care about whether the network's running, is it fast, is it available. You know, the security guys want to know who's doing what within the network and what's going on. But if I talk to a marketing director, they're really worried about brand awareness and brand protection. And the last thing they want is a data breach that then results in their brand being hit. And you can just see what it does, like the CrowdStrike. It wasn't a DNS attack, but they had a challenge and a problem with what they did for Microsoft servers that severely affected their underlying share price for a while. You know, people look at it and they look at what's happening in customers. And you get a data breach, it really does affect your brand. So marketing guys are aware of it. They're concerned. It's just about trying to work out who's got the budget to pay for it more than anything else. And then the last one is being able to test whether or not it's possible to exfiltrate data through a customer's network. And we've got a tool that we can help to show that. It takes about 5 minutes to run a demo with a customer. We can register them on a website, they get a web page to go to, they can put some text in a box, press a button, and it will try and exfiltrate data through the network. You can also generate the queries on a WebEx when you're running it, send them the queries, and they can run it through the command line. With some customers, they don't even have to read the email because their email filter will pre-scan it and will make the DNS queries. And I've had customers on a WebEx where I've run the web page, cut out the queries, sent them an email, and we've just watched the queries being received by our DNS server and decrypted, and the data pops out. They haven't even opened the webmail. You know, their email filter's done it for them, and it's exfiltrated data. And it's gone through the protections they've got in place in their network, and it's shown that they can exfiltrate data. Now, we do that for a lot of customers where the customer wants to know, can you exfiltrate data through my network? Sometimes, no, you can't. You know, the best outcome for a customer is where we see 3 or 4 queries come through and then nothing. Because that generally means they've got good protection in place for exfiltration. And it gives the customer a nice, warm, cozy feeling that, okay, they're protected. Mostly, you can do it straight through. And we've done it for a few CISOs around the world that have been, I won't say scared, but very concerned that it was that easy to put data from inside the network to outside the network, and all their existing controls just let it go through. So if you want to do that with customers, talk to the CSAs. It literally is a 5-minute test. And there's also the other aspect. This is an opportunity for professional services. You know, if customers want someone to come in and do an analysis of their existing DNS infrastructure and what's possible using that infrastructure, you know, we can do it. PEB's team can do that as a service. If you've got the skills, it's something you can offer your customers to do an analysis of their DNS as well. But that's a good start point to show customers where they're vulnerable, because mostly they won't know. And I'll extend this to everyone in the room, right? You guys, with us, we're supposed to be the experts in the eyes of our customers. We're just an extension to you, right? So when we come on customer calls with your customers, we should be one team pointing out to the customers where their vulnerabilities are. And it scares them sometimes. So if we look at DNS security specifically as a differentiator, I mentioned Infoblox were the only other company other than us that do the behavioral stuff. The one challenge they've got is a lot of what they do is cloud-based. So to do the full exfiltration protection, you need their Blocks 1 threat defense, probably the advanced or whatever they're calling it now. I think they still charge for DNS firewall as an extra module. We just have it built into the DNS. But the one thing I would say about what they do is it's very, very US-centric, right? The original Infoblox threat data service came from an acquisition of a company in the US that primarily worked with the Department of Defense and the NSA in America. So their feeds are very, very biased towards protecting US interests. Once you get outside the US, it's not so great in Middle East, Africa, Asia. So you've got multiple products that you need to buy. You've got a US-centric organization. They can stop DNS exfiltration, and it works. Blue Cat, it's a little bit limited in that it has the DNS firewall and the ability to block based on queries. they have a measure of protection at the edge, but they don't do the same level of inspection of the packets and tracking of user behavior. They will integrate with Umbrella though. QIP just has DNS firewall. They don't have anything else. Same for BT Diamond, same for Microsoft. So if customers are serious about DNS security, there's really only two horses in town that they can ride out on. And we always think we're lower in TCO than they are, so that gives us the advantage. Any questions? And again, I've added a ton of stuff at the back end of this that goes through the different types of attack you'll see at the DNS level, whether it's volumetric, exploit, stealth, or just protocol abuse. There's a bunch of slides after, but they're a bit technical and I'm not going to bore people to death with them. Any questions? Okay, in that case, thank you. The next presenter will be Peb, who will go through our vision and our roadmap. Thank you.
Thank you, Richard.